Hi guys, I wanted to talk about crystal field theory. The octahedral part of the crystal field theory tells us that an octahedron is formed from the three cardinal axes. So we have the third dimension here. An octahedral is a product of the third dimension. And what we have is the X, Y, and Z axes, Z being vertical like that. They talk about having 6 negatively charged ligands, they call them. And so these ligands are on the corners of the octahedron like that. In the center is a positively charged atom that they call a cation. And what they tell you is that the ligands, they converge toward the positively charged cation, and then they merge, and it creates a sphere, a spherical energy bubble. Joe Parr mentioned a spherical energy bubble before. And so with that understanding, you can understand the foundations of the earth as recorded in Job chapter 38, like I've mentioned before in previous videos. And you could also understand the origin of heaven, the origin of life. It's right there. So I'll play that for you. And now we understand why we have a spherical Earth. We have a spherical celestial sphere. We have a spherical glass bubble in the sky. Actually, probably a couple of those. And it all has to do with the understanding of crystal field theory and product of the spherical energy bubble that is created by the convergence of the negatively charged ligands converging in the center. Also note is that the Libyan desert glass is a quartz crystal. So that's a really good indication that the glass up in the sky that fell down in the Libyan desert is part of the glass sky, part of the glass bubble, the glass sphere in the sky being a product of the octahedron. Play a little bit of this video here on YouTube where it explains it a little bit.
It is assumed that the ligands would approach the metal directly along the X, Y, and Z axes. Would have their own negative field surrounding them. But when they all come together around the metal cation, they effectively form a spherical field around the metal.
So there you go. They form a spherical field around the metal, around the center cation. So that's a really good indication that the spheres are formulated from the octahedron, the foundations of the earth, as I mentioned before. Once you have your foundations of the earth correctly understood, everything else is built upon it properly. And then you understand you're living inside the cellular concave earth. A little bit more here. And then within crystal field theory, there are actually orbitals where the electrons supposedly flow. And so they have 5 different orbitals here. We have the dz squared or z squared orbital going along the vertical z-axis. This one is actually distinct from the other 4 orbitals because it actually has a toroidal shape that's aligned with the X and Y axis, and that's really interesting. I'll get into that later after I describe the other orbitals here. And we have the dx squared minus y squared orbital, which is aligned with the X and Y axes as well, but going right along them like that instead of toroidal like the dz squared orbital. Those are the 2 main orbitals. The 3 inferior orbitals, I'll get to those, I'll show you those. This is the dxy orbital, but these orbitals are not aligned with the ligands, so they're going halfway between the ligands. And then you have the dxz orbital, and finally the dyx orbital, like that. But going back to the initial orbital, that actually is distinct from all the other orbitals because it has a toroidal shape in the center there. And now you can understand why we have an equator, why there's activity at the equator, that the northern hemisphere versus the southern hemisphere, there's like the reversal There's a reversal of hurricane movement. There's a magnetic equilibrium that we can feel with Foucault's pendulum, for instance. The pendulum will not spin at the equator. And so with this understanding, that's why we have an equator in the first place, like that. And so this field that emanates out, it creates an equatorial equilibrium. That's why satellites can actually levitate at these cardinal corners of the base of the X and Y's. And that's why we have the doldrums within the Earth. It all has to do with the understanding of crystal field theory, octahedral crystal field theory generating in equatorial region with the dz squared orbital. So that's understood. Everything is finally understood. Okay, foundations of the Earth have been found. And you're living in the concave cellular Earth. And if you haven't, I'll put links into my other videos where I talk about the octahedron in the center of the Earth. It's actually visible with radar imagery. Canadian meteorological oh, I can talk. Observatory, whatever, they showed data imagery of the actual octahedron. So check that out and understand. Thanks for watching. Have you ever watched any of the Ken Wheeler's videos? You know that guy?
The what videos?
Ken Wheeler, he talks about magnetism.
No.
He's got some interesting videos. He's a real smart guy. But one of his videos was really interesting because, well, a lot of them are interesting, but he has this really huge neodymium magnet. It's like 8 inches wide by 4 inches thick. I'll screen that.
What did he do?
Well, he's explaining the difference between the center, which is exhibiting a centripetal convergence vortex in the center, and then as opposed to along the perimeter, or along the edge, which is a centrifugal divergence. And so, actually, I kind of associated that with what's going on with the Earth, with the center spinning, because he took this gyroscope. Let me just share the screen here.
Did you ever see this? Did you ever see the?
He took this gyroscope.
No, go ahead.
Go ahead. He took this gyroscope and he spun it. He spun it up. He wound it up and he spun it, and he was saying that nobody's ever explained this before. No physics professor or anybody, and that is that there's, even though there's like the Gauss reading is the same between what's in the center as far as magnetism goes and what's along the edge, it's exhibiting a different field, I guess. Basically, you got this in the center. You got this centripetal convergence where the flux lines are converging, but along the perimeter, they're diverging, and so you can spin this gyroscope, and it can spin forever if it's just held in the middle. But when you bring it out to the edge like that, it's not touching the edge; it's just getting near to the edge. It stops automatically like that. And so I kind of compared that with what's going on with the Earth. We have a stationary Earth, but we have the ether movement within the Earth. Well, that's really annoying. I'm getting some audio shit going on here. So I thought that was interesting. We got this rotating celestial sphere in the center, which is actually being perpetuated by this frictionless centripetal convergence force. And then along the edge of the Earth, it's stationary. So we have this divergent force of the ether, or the magnetism, or whatever you want to call it.
Hmm.
Can you like elaborate on how the spinning of the celestial sphere? I believe it does help, um, right, keep everything grounded. I'm not really sure. I
Well,
probably need to watch some more videos, but you probably discuss this if you don't mind.
well, think of magnetism. You think octahedral shape is magnetite. Magnetite is the most magnetic mineral in all the world, and its base shape is octahedral, and so that coupled with the radar imagery, with the equatorial equilibrium points, we can understand that there's an octahedron in the middle of the Earth, and with crystal field theory, there's good reason to believe that it creates the spheres. And then with the magnetism or the magnetic flux, there's good reason to believe that this sphere or the initial sphere around the octahedron is spinning. And Ken Wheeler actually talks about that because he talks about centripetal convergence and centrifugal divergence. And the difference, even though there's, he gives an example of this large disc-like neodymium magnet, and he puts a gyroscope in the center of it, on the top of the center, and the gyroscope continues spinning. It's not affected or impeded in any way by friction or anything like that. The magnetism actually propagates the spin or keeps it spinning. But when he brings that gyroscope to the edge, that's where this centrifugal divergence of the magnetic flux is happening. So it's actually breaking the gyro. It stops, puts the brakes on the gyro, and the gyro stops spinning. So I think that's a good analogy of what's going on with the magnetism in the Earth. In the center, we have this centripetal convergence where the magnetism is free flowing and it's just continually spinning. But the edge, we're living in the edge of the Earth, and there's no spin to the Earth, therefore, because of the centrifugal divergence of the magnetic flux.
It's very interesting. It made me think about Tesla.
On board, the team reviews the stunning and unique images. This sprite was shaped like a mangrove tree. It's been captured in more detail than any sprite until now. Just like its name, this sprite evokes a fairy with wings.
Yeah, very big jellyfish. It's pretty. Very pretty.
It indeed looks like a jellyfish with many tentacles. Sprites of many different forms appear, one after another. Seen up close, they have a variety of shapes. Eventually, a sprite appears that demands special attention.
This is spectacular.
The umbrella-like top of this sprite reaches an altitude of around 60 miles.
But I'll repeat myself. I was talking about the refraction of light. And I was asking Eric, I was saying that the longer the wavelength, like in the visible spectrum, the red is a longer wavelength than the violet. And so the red is going to refract the least out of all the colors. It's going to be at like 750 nanometers versus the violet, which will be about 380. And then I was looking into marine radar, boat radar, and I made a video about this before. But the standard explanation of boat radars, they will tell you that the longer wavelength bends more because they're believing that they're living on the convex surface of the Earth. That's not the case.
Holy crap, I never thought of that.
Well, and also, I don't know if you see that, let me share the screen again. Because I took this table off the site.
Yeah. Plus, the surface of the water should act like, what is that called again? You know, all the cracks in the glass cause it?
The Luxembourg effect?
Yeah.
But even in this on this table here, it has a table of the refraction of light in air. Okay, and they have the conditions, the pressure, the wavelength. And so I highlighted these 3 different scenarios here. One at 300 nanometers, which would be a shorter wavelength, and 1700 nanometers would be the longest wavelength, and 633 would be, middle in between. And so the longer the wavelength, 1.000268, it's not bending as much as the shorter wavelength. The shortest wavelength is bending at 1.000286, so it's actually bending more. So the shorter wavelength bends more, not the longer wavelength. And so how can they get away with preaching that bullshit about saying that the longer wavelength bends more? It does not bend more. You can just look at the visible spectrum through a prism there. The red is the longer wavelength, and it is bending less.
Is that number a volumetric? Like, because you would think the index of refraction would change the more water it goes through. So how could they give like a set number without like a volume, like refraction per volume? Something, you know what I mean?
Well, they're all at the same conditions, the same temperature, the same humidity, the same pressure. So they're all compared under equal conditions. So, I mean, but they've gotten away with this for so long, That's why they can't really talk about it that much, because somebody can just out them. This is bullshit.
This is a global earth argument, right? Not a flat earth argument, right?
Huh?
Who's presenting you this challenge? Is it a globe earther or a flat earther?
Neither. I was actually just looking into some research to talk about with WAPTEC here, and he thinks that the Earth is convex. Well, if it's convex.
Okay, so globe earther. It was a globe earther.
Yeah, globe earther, whatever. But
okay, because I was going to say that when I start seeing information that technical, right off the bat, I know, oh my God, it's not a flat earther, because they never go that deep. It seems like the people who do have some mathematical strength, intellectual strength, they're still kind of stuck on the globe. You'll never see a flat earth show you a chart or numbers, or some kind of ledger.
Yeah. So what I did was I turned that prism upside down, because it's easier for, I think, people to understand. If you're living on the inside, the concavity of the Earth, you have the red on the bottom here. The red is bending less than the violet. 750 nanometers versus 380 nanometers. So the shorter wavelength is going to bend up more away from the Earth as opposed to the longer wavelength. And especially when you get into the longer wavelengths like the microwaves and the radio waves. That's why you can see more with infrared waves, which are, they're longer than the reds here. You can see more with an infrared camera than you can with a normal light camera, because it's a longer wavelength. So it's the same with radar. You can see your range in radar, in boat and marine radar, is greater when it's beaming out longer wavelengths.
Well, actually, you know what I just...
Seasons within the concave Earth. I animated the sun oscillating around the celestial sphere every 6 months. So when it's in the Tropic of Cancer, you'll notice that you get 24 hours of daylight at the North Pole and 24 hours of darkness on the South Pole. And conversely, when the sun is in the south, you'll see that you will get 24 hours of daylight on the South Pole and 24 hours of darkness on the North Pole. Originally, when I animated the sun, I did it linearly. There was no acceleration or deceleration, so I couldn't get the equinoxes to line up on March 21st or September 21st. However, when I added acceleration and deceleration, so it's decelerating at the extremes like that, the equinoxes lined up perfectly. And so in nature, you can conclude too that if something is orbiting around something magnetically and it's oscillating north and south like that, there's going to be acceleration and deceleration. In a heliocentric model, you have to conclude that the Earth is orbiting around the sun in an elliptical path. It's very unnatural. You also have to conclude that it's tilting. You have problems with that too as well. And you also have to conclude that it's precessing or wobbling, because it shows that after a year the sun is in a different location against the stars. But if you understand, within the concave Earth, it's all taken care of simply by the fact that there's two different velocities, the velocity of the sun and the velocity of the celestial sphere, which is slightly faster than the sun. A sidereal year, or a sidereal day, is 4 minutes faster than the sun. So after a full year's time, the sun is simply just going to be 1/70th of a degree in a different location than the year before. The planets are all magnetically affected by the sun. So when the sun is inclined like that, the ecliptic of the planets, that magnetic ecliptic imaginary path, is going to be influenced by it as well. There's a real retrograde motion to the planets. It's not just an apparent retrograde motion caused by a supposed spinning Earth. It's simply the fact that when the planets go behind the celestial sphere opposite the sun, they're going to get confused magnetically. So they're going to go the other way for a little bit until they catch up with the sun's influence again, and then go the same way that they were going before. Mercury and Venus, they're going to be orbiting the sun. So when they go behind the sun, they're going to get confused as well. So that's how retrograde happens within the concave Earth. The Milky Way band, it's a band, it's not a spiral galaxy. It's actually a literal band that separates the celestial sphere into two different hemispheres, two different magnetically influenced hemispheres that actually steer the sun. So the Milky Way band has a function. So when the sun crosses that galactic plane every 6 months, it's also exhibited by the Ulysses satellite. They show that every 6 months the sun is oscillating back and forth. So when it crosses that plane, it steers the sun in the other direction. Like when it's up north like that, it's going to steer the sun south, and then conversely the same when it goes down south. When the sun goes down south, when it crosses that plane, it's going to steer the sun back up north. So it's all being influenced by that dividing line, that Milky Way dividing line. It has a purpose, it has a function. Everything works within the concave Earth. Sunlight is bending around the inside of the Earth. That's how we get lunar eclipses. There's an opposite funnel-shaped void area opposite the sun. When the moon goes through that void area, it gets eclipsed. North or south of that void area, it's just simply going to be a full moon. So everything works in the concave Earth. You've seen my animation here, I made it a wide angle, so I wanted to include everything, so that's why it kind of looks kind of funky, but it's Occam's razor. The simplest answer is always the best answer. So.
The lift force and the sink force of the electromagnetic flux. There's an inversely proportional relationship between the two. Blue arrows represent the centripetal convergent lift force. It draws objects to the center, where the current is attracted to the moving convex surface of the celestial sphere. The lift force is stronger in the center and weaker at the edge. That is why planets have such an easy time staying aloft toward the center, because there's not that much sink force and plenty of lift force. If it weren't for the magnetic sun attracting the planets, they probably would crash into the celestial sphere. The lift force cohabitates with the centrifugal sink force, which has the inverse proportion effect. The sink force is the ether push force we all experience on the Earth, or in the Earth. As it moves, the divergent fluxes put the brakes on the Earth, preventing any rotation. Remember Wheeler's gyroscope on his huge neodymium iron-borne magnet? The centripetal lift force perpetuated the magnet in a viscous free flux near the center. Yet the centrifugal divergent sink force stopped the gyro on the edge. That's what's happening with the Earth. The sink force generates a depression to the west. That's why bullets sink to the west and rise to the east, because there's a greater clamping down effect for projectiles shot into the downstream of the sink force. This is also what causes eastward deflection of flying objects. They seek the least resistance, which will always be found eastward of the meridian. The sink force is so strong at the edge it holds the water at bay. The ether's sink force eliminates the Coriolis or the Atmos effect from being the cause of this phenomenon. Since you should know by now, we are not on a rotating planet. Now we can understand what causes gyroscopes to liberate themselves from the thick sink force happening at the edge. The rotation of the gyro is stripping off its sink force hold and aligning itself with a much weaker lift force at that level to allow it to rise. The vertical axis seeks to magnetically align itself with the central octahedron. That's why the airplane gyro stays pretty much vertical wherever it flies within the Earth.